His hands find the bolt without looking. 15 years on this line teaches you that. He's tightening the last piece onto a bare chassis. Bolted, not welded. A whole car held together like this, made to come apart just as easily as it went together. Lift the hood and something strange happens. The entire front end swings forward, hinges wide, engine sitting exposed like an open book. Nobody built cars this way back in 1959. One furious phone call from a rival forced Triumph's hand completely. "Tell me where you're watching from tonight, then we'll go back to that call." The call came from London, not Coventry, and it landed like a slammed door. Leonard Lord ran BMC, and BMC had just swallowed Fisher and Ludlow, the company that pressed body panels for half of Britain's small cars. Standard Triumph needed a body for its next car. Lord made sure they wouldn't get one from him. Harry Webster took that news and didn't panic. He ran engineering at Standard Triumph, and he had a factory full of workers but no big press shop that could stamp out a one-piece body shell. Every other British car maker built that way. Steel went in one end, a finished shape came out the other, and you needed serious money and serious machinery to pull that off. Webster had neither. So he asked a different question. What if the body didn't have to come out in one piece at all? Money was part of the problem too. Standard Triumph had spent heavily on a front-wheel drive saloon a few years earlier, and that gamble hadn't paid off the way anyone hoped. There wasn't a spare fortune sitting around for new tooling. Whatever came next had to work with what the factory already had, not with equipment nobody could afford to buy. Inside the Canley works, the answer took shape slowly, panel by panel. Small suppliers, the kind who couldn't afford giant presses either, could still stamp out doors, wings, and roof sections in modest batches. Bolt those pieces onto a separate steel chassis instead of welding them into one shell, and the whole problem disappeared. No giant press needed. No dependence on a rival who'd just proven he couldn't be trusted. Picture the frame on its own, bare and skeletal, rolling down the line before a single body panel touches it. Workers attach the front wings first, then the doors, then the roof, each piece arriving from a different supplier, each one bolted on rather than fused. Spanners, not welding torches, held this car together. Listen closely on the shop floor and you'd hear it too, the clatter of ratchets instead of the constant hiss and pop of a welding bay. A strange sound for 1959, a smart one as it turned out. The whole front end, bonnet, wings and grille combined, hinges forward as one unit, swinging up like a lid to expose the engine underneath. That's the detail from a moment ago. Now you finally know exactly why it's built that way. Giovanni Michelotti gave that skeleton its shape. The Italian designer worked fast, and he understood something the accountants back in Coventry badly needed to hear. A car built from separate panels could still look like one clean, confident design, if the man drawing it knew what he was doing. Michelotti sketched a two-door saloon with a low waistline and glass running almost the whole way round the cabin. 93% all-round visibility, the finished figures would later claim. Drivers could see out of it better than almost anything else on the road, and driving instructors across Britain noticed within a year. Rack and pinion steering went in too, sharp and direct, paired with a turning circle so tight the car could practically spin on the spot. None of that came from a marketing brief demanding excitement. It came from engineers with limited money, solving one problem at a time and refusing to let any single decision cost more than it had to. None of this happened because Triumph wanted to reinvent the car. It happened because one phone call cut off their easiest path forward, and an engineer with no other option found a harder one instead. Here's what nobody at BMC saw coming. A bolt-together body isn't just cheaper to build. It's flexible in a way a welded shell can never be. Change the roof panel, and you've got a coupe. Stretch the rear, and you've got an estate. Drop the top, and you've got a convertible. Built on the exact same bones as the saloon rolling off the line right beside it. Webster and Michelotti had built more than one car. Without meaning to, they'd built a kit, and that kit was about to travel a lot further than either of them ever expected. Travel it did. Crates left Coventry by the thousand, packed not with finished cars, but with pieces of them. Chassis rails, body panels, engines wrapped in grease paper. Dock workers loaded them onto ships bound for places that had never built a British car before. and none of them needed a factory full of expensive tooling to put one together. Salt air and diesel fumes replaced the smell of a Midlands assembly hall, but the job underneath stayed the same. Bolt, don't weld. That was the whole point. A bolt-together car needs bolts, not a stamping plant the size of a football pitch. Standard Triumph called this CKD, complete knockdown, and it turned the Herald into something closer to a flat-pack car than anyone realized at the time. Workers in Ireland, South Africa, and New Zealand assembled kits shipped straight from England, each crate arriving with instructions written for hands that had never touched a Triumph before. In Madras, a company called Standard Motor Products built the same car under its own name, the Standard Herald. They kept building it long after Britain had moved on to something else entirely. A design born from one company refusing to hand over a body supplier ended up rolling off assembly lines on 3 different continents in 3 different climates. Most of the people driving it had likely never even heard the name Leonard Lord. None of that would have worked with a welded one-piece shell. Ship a finished body across an ocean, and you're paying to move mostly empty space, wrapped around a lot of expensive steel. Ship loose panels stacked flat in a crate though, and you're moving the same car in a fraction of the room. The Herald's whole design, born out of desperation back in Coventry, turned out to be exactly what a global market needed. Nobody planned that part. It just happened to fit. Here's where the story gets more interesting than an export ledger. That same chassis, the one built to solve a supply problem, turned out to be a perfect foundation for something else entirely. Shrink the floor pan down, drop the doors, and you've got a 2-seat sports car with an open top. That car became the Spitfire, and it used a shortened version of the exact platform sitting under every Herald saloon in the country. Stretch the idea a different direction, and something bigger appears. Keep the full Herald chassis and body structure intact, but swap in a 6-cylinder engine where the little 4-cylinder used to sit. You get the Vitesse, a genuinely quick small saloon wearing the same bones as a car built for families and driving instructors. Buyers who wanted a saloon that could actually keep up with faster traffic on the motorway suddenly had one, without Triumph designing a single new chassis rail to get there. From there came the GT6, a proper coupe with real performance, still tracing its lineage straight back to a bolt-together platform designed to survive a boardroom snub. 3 cars, 3 different price points, 3 different customers, and one underlying skeleton doing all the work behind the scenes. One idea. 4 completely different cars, wearing 4 completely different badges, sold to 4 completely different kinds of buyers. A grandfather could drive the saloon to church on Sunday, while his grandson raced a Spitfire built from the very same parts bin. Neither of them likely knew how closely related their cars actually were under the skin. If you're the kind of person who likes finding out how one clever decision quietly reshapes an entire lineup, stick around and hit subscribe, because the platform's reach goes even further than what you've just heard, and the next part explains exactly where that flexibility finally ran out of road. Think about what that means for a company that started this whole project with nothing but a rejected phone call and an engineer refusing to give up. Standard Triumph hadn't just solved one problem, it had built a toolkit flexible enough to answer questions nobody had even asked yet, in countries its own engineers would likely never visit. But flexibility has limits, and the Herald's cleverest trick was about to reveal its most dangerous flaw. Take that same Herald onto a wet roundabout at speed, and something changes underneath it that no brochure ever mentioned. The rear suspension used swing axles, a design where each rear wheel pivots on its own, independent of the other. Independent rear suspension was genuinely advanced for 1959. Most family cars still rode on a single solid axle, the kind that dragged both rear wheels through a corner together, for better or worse. Triumph's engineers had built something more sophisticated instead, and on paper, more sophisticated should have meant safer. Push it hard enough though, and a swing axle does something a solid axle never does. The outer rear wheel can tuck under the car mid-corner, the tire's contact patch shrinking away just as the driver needs grip the most. Engineers call it jacking, the body of the car actually rising up over that wheel as it folds inward. Feel it happen once, and you understand instantly why driving instructors across Britain both loved and feared this car in the same breath. That's the twist worth sitting with. The same tight-turning circle that made the Herald a favorite for learner drivers, the same nimble, forgiving feel that made it easy to park and easy to trust at low speed, hid a completely different personality once someone pushed it past where an ordinary driver ever would. Slow and steady, the Herald behaved like a gentle, easygoing little saloon, fast and committed, especially on a damp road with a full load of passengers in the back. It could turn on you without much warning. Racers found this out long before ordinary drivers did. Club competitors entering Heralds and their six-cylinder Vitesse cousins into local events quickly learned to respect the rear end, adjusting their lines and their throttle inputs to keep that outer wheel planted. Some fitted stiffer springs or extra dampers just to calm the behavior down before a race. Word passed between drivers the way it always does in a paddock, quietly, through shared experience rather than any official warning from Coventry. Get greedy on the exit of a fast corner, and the car would tell you about it, usually right when you had the least room left to correct. Here's the detail most people miss entirely. Triumph knew about this behavior. Engineers refined the rear geometry across the Herald's production run, and later Triumph's moved toward more sophisticated setups, specifically to tame what the swing axle could do at the limit. That refinement never fully erased the character built into the earliest cars, though, and plenty of first owners never even knew there was anything to refine in the first place. If this is the kind of hidden detail you want more of, drop a comment and stay subscribed. What happened next connects this flaw straight back to everything you just heard about exports. Remember those crates leaving Coventry, bound for climates nobody in the Midlands ever had to drive through? Picture a Herald assembled in South Africa, tackling a wet mountain pass instead of a British roundabout, its rear wheels meeting camber and loose gravel nobody back home had ever accounted for. Picture one built in Madras, navigating monsoon rain on roads that flooded without warning, loaded with passengers the way family cars always end up loaded. The same rear suspension that surprised a driving instructor in Surrey now had to answer for itself on roads its designers had never seen, in weather they'd never once tested against. Nobody at Standard Triumph planned for that collision between clever engineering and unfamiliar conditions. The chassis that traveled so easily by ship carried its one real weakness along with it, unchanged wherever it landed. A car built to be endlessly adaptable turned out to have exactly one thing that didn't adapt at all. That's the real secret behind the Herald. Not a hidden button or a buried feature nobody found. A trade-off, built into the bones from the very beginning, riding quietly under a car that thousands of families trusted completely, on roads all over the world, without ever knowing it was there. The cleverness that let this car cross oceans, and the flaw that could catch a driver off guard, came from the exact same design, inseparable from each other, from the very first bolt. Somewhere right now, a bolt turns on a Herald just like it did on that Canley line decades ago, holding together a car built to travel the world with one flaw riding along for free. Have you ever felt a swing axle let go mid-corner? Tell me exactly what happened, below.